What if every single human being on Earth pointed a laser at the moon at the exact same time? Would it change color? Would it even matter? The answer starts completely boring and ends with us accidentally launching the moon out of the solar system. Stick around, because the journey from nothing happens to planetary catastrophe is wilder than you think. Act 1. The setup. Why this is harder than it sounds. Before we even fire a single laser, we have a geometry problem. You can't see the moon from everywhere on Earth at once. Half the planet has daylight, half is facing the wrong direction. Our best shot: wait for the moon to hang over the Arabian Sea. That's when the most people have line of sight. We pick a quarter moon so we can compare results on both the lit side and the dark side. Fair test. Now we're ready. Everyone gets a standard red laser pointer, 5 milliwatts, the kind you've accidentally blinded yourself with during a boring presentation. We fire. Nothing. Here's why. The sun is already blasting the moon with over 6 petawatts of energy. That's a 6 followed by 15 zeros. Our 8 billion little laser pointers combine for roughly 30 megawatts. That's 200 million times weaker than sunlight. We didn't even tickle it. Act 2. Escalating the absurdity. Okay, more power. We upgrade everyone to a 1-watt laser, the kind that can blind you, burn skin, and set paper on fire just by looking at it wrong. These exist. They're technically legal to own in the US, but they're sold online under sketchy names like 1W blue flashlight, very narrow beam, wink. If you've seen one in real life, you know they're terrifying. We spend $1 trillion arming every person on Earth with one. We fire. The moon receives about half a lux of illumination. For reference, moonlight here on Earth is roughly 1 lux, so we've achieved half a moonlight on the moon. The sun's 130,000 lux laughs at us. Still nothing visible. Let's keep going. We ditch laser pointers entirely. Everyone gets a police helicopter's searchlight, the night sun, capable of turning a pitch-black field into broad daylight. We add focusing lenses to tighten the beam enough to reach the moon. Now we're getting somewhere. The dark side of the moon is actually lit up, twice as bright as ambient lunar night. That's genuinely impressive. But the sunlit side? Completely unaffected. More power. IMAX projectors, 30,000 watts each, over 1 million lumens per unit. Barely visible improvement. The Luxor Hotel Spotlight, one of the most powerful on Earth, one for every human with a color filter and focusing lens. Now we can see the color change. Mission technically accomplished, but we're not done. Act 3, where physics gets violent. We go back to lasers, military grade this time. The Boeing YAL-1 was a megawatt-class infrared laser literally mounted inside a 747. The US built it. It was real. We imagine a visible light version and hand one to every person alive. Combined output, 5 petawatts. That's double the entire world's average electricity consumption. But finally, our beam matches the brightness of sunlight on the moon's surface. Still not enough to change its color to the naked eye. So we go further. We cover every square meter of Asia in megawatt lasers, 50 trillion of them. To power this, we burn through Earth's entire oil reserves in 2 minutes. But for those 2 minutes, the moon glows as bright as the morning sun. The lunar surface heats up and begins to visibly change. We've done it. What if we tried more power? Act 4. The point of no return. The most powerful laser ever built is the National Ignition Facility's confinement beam, 500 terawatts of ultraviolet light. It fires in pulses lasting nanoseconds. The total energy per shot? About a quarter cup of gasoline. We imagine powering it continuously, one for every person, all aimed at the moon. First problem, the lasers turn the atmosphere into plasma and ignite the Earth's surface instantly. We pretend that doesn't happen. Second problem, the reflected light bouncing off the moon is now 4,000 times brighter than the noon sun. The Earth catches fire anyway. We pretend that doesn't happen either. So, what happens to the moon? The lasers vaporize 2 meters of rock per second. The surface layer becomes superheated plasma. That plasma gets blasted into space at incredible velocity, and here's where it gets genuinely mind-bending. We've accidentally turned the entire moon into a rocket engine. This technique, using lasers to blast material off a surface to generate thrust, is called laser ablation, and it's actually being studied as a real method for spacecraft propulsion. The moon is massive, but the plasma jet we've created is relentless. Within a few months, the moon has been pushed beyond our laser range. In the process, the jet scours the surface of the Earth completely clean, but we're pretending our lasers are invulnerable. So we watch as the moon, still largely intact, breaks free of Earth's gravity and enters a chaotic orbit around the sun. That orbit is unstable. Eventually, the moon gets slingshot into the sun, flung into the outer solar system, or slammed back into Earth. If that last one happens, we probably deserved it. So, can 8 billion laser pointers change the color of the moon? With regular ones? No, not even close. But push the physics far enough, and you don't change the moon's color, you lose the moon entirely. And that is enough power.